Good morning all. Welcome to next lecture which is related to the basic concept of equation and various types of equations. Here we will cover what actually the equation means and what are the various types, and also we will discuss the solution to a linear equation. See, equation in economics are necessary tool for modeling, analyzing, decision making, and also understanding various economic phenomena. The basic economic model of supply and demand analysis is actually expressed through equations as well. See, the equilibrium condition where the quantity supplied equal to the quantity demanded, which is usually represented mathematically to analyze the market behavior as well. See, mathematically, we can say that it is used to analyze the market behavior. See, similarly, the equations were also used to analyze the cost function, revenue function, utility function, production function, and other macroeconomic and econometric modeling. So let me define what actually the equation means. See, equation is a mathematical statement. It is simply a mathematical statement setting two algebraic expression equal to each other. Two algebraic expression equal to each other, which is called an equation. So simply an equation is a statement of equality between two expression. It is simply the equality between two statement, or it is two expression, and it is generally consist of variables, constants, and mathematical operations such as addition, subtraction, multiplication, division, exponentiation, and more. See, the equality sign, that is equal to is used to denote that the expression is either side of the equation have the same value. And these are the essential tools for solving the mathematical problems. And basically these equations provide a systematic way to illustrate the relationships and help to find unknown values of the variable. Consider some example so that it will be more clear. See, 2x is equal to 6. 2x is equal to 6. It is a simple linear equation with one variable. It is x is the variable, and we are setting two algebraic expression, that is 2x is equal to 6, that is equal to each other. So here, in order to solve the x, you can isolate the variable x into the one side, dividing both side of the equation by 2, then x is equal to 6 by 2, which is equal to 3. See another example, 3x plus 5y is equal to 10. And this is a linear equation with two variables, that is variables are here x and y. So we have a different types of equations as well. I hope you understood the concept of equation, and now we will move towards various types of equation as well. See, equations are generally categorized into various types, depending upon their structure, the number of variables involved, and the nature of mathematical operations. See, we will discuss here some of the common types of equations. We have a linear equation. See, an equation in which all variables are raised to the first power is known as a linear equation, similar to a linear function. So a linear equation is an equation of a first degree, meaning that the highest power of the variable will be 1. So the linear equation take generally, for example, ax plus b is equal to 0. See here, x is the variable, a is the coefficient of x, and b is the constant term, which is equal to 0. So the solution to a linear equation shows that the value of the variable that satisfy the equality. For example, see x minus 3 is equal to 2. We can solve this x by adding plus 3 into the both side. Minus 3 plus 3 will be cancelled out. 2 plus 3, which will become 5. So x is equal to 5 here. So this is one of the example of a linear equation. Now we have a different types of linear equation as well. See, linear equation generally represented a straight line, which we are already discussed in the previous lectures. So when a graph on a Cartesian place, if you go for graphing a linear equation, they will have a straight line. And they can involve one variable, two variable, or maybe three variable. See, let us see, there are various types of linear equation based upon the number of variables involved. See, we have a linear equation with one variable. We have a linear equation with one variable, that is 2x plus 3, which is equal to 7. It involves only one variable here, that is equal to x. So typically denote it is an x and can be represented on a Cartesian plane, by using a straight line. Similarly, we have a linear equation with two variable. For example, see, 3x plus 2y is equal to 10. It involves two variables. Here we have a variables are x and y, which is generally denoted to utilize to denote two variables, that is x and y. And it represents, a straight line when you graph a Cartesian coordinate system. Similarly, we have a linear equation with three variables as well. See, for example, 2x plus 3y minus z is equal to 5. See here, we have a three variable which is often denoted in terms of x, y and z, which represent in the plane in the three-dimensional space. When you go for graphing of this particular linear equation with three variable, then it will be a three-dimensional space rather than a line. So these are the fundamental types of the linear equation based upon the number of variables they contain. So each type has its own characteristics, and we have a different methods for solving these type of linear equations. Now we have another type of equation which is known as system of equation. See, a system of equation is a collection of two or more equations involving same set of variables. See, the solution to a system of linear equation is a set of values for variable that simultaneously satisfy all equations in the system. And system of an equation can be classified based upon the number of equations and the number of variables they involve. See, a solution to a system of equation is a set of values for variable that satisfy all equations simultaneously. So there are different methods to solve the system of equation depending upon number of variables and equations involved that we will discuss later. So the system of equation, which may be a system of linear equation with two variable, or it may be linear equation with three variable as well. See, a set of linear equation in which there are same number of equation and unknown, which is generally known as it is a simultaneous equation. What is happening here? A set of linear equation in which there are same number of equation and unknowns are called generally it is a simultaneous equation. And a solution of a system of linear equation is an ordered pair, that satisfy both equation at the same time. Mainly it is at the intersection point. So the standard form of the linear system of two equation with the two variables are, it is ax plus by which is equal to p, cx plus dy which is equal to q. So here a, b, c, d are the coefficient of the concerned variables and x and y are the variable here. So for example, take the system of linear equation with the two variable case. See, 4x plus 3y which is equal to 11, 2x plus y is equal to, we have a two linear equation with the two variable that is x and y. Similarly, we have a system of linear equation with the three variable as well. An equation with one variable require only one equation to have a unique solution. Similarly, the equation with the two variable require two equations to have a unique solution. So, it would not be surprising that the equation with the three variable require the system of three equations to have a unique solution. So, an equation with one variable require only one, as we are said. So, if you consider the standard form of a linear system of three equations with the three variables, see here, ax plus by plus cz is equal to d1, Ex plus Fy plus Gz is equal to D2, Hx plus Iy plus Jz is equal to D3. See here, A, B, C, D, E, F, G, H, I, J. These are the coefficient of the, coefficients of variable x, y, z, and D1, D2, D3 are the constants, and x, y, z are the variables here. Consider an example of linear equation with the three variable case. See, x plus 3y minus z is equal to 4, 2x plus y plus 2z is equal to 10, 3x minus y plus z is equal to 4. So here we have the three equation and three unknown variables are here, that is x, y, z. So the system of linear equation, if it is three variable case, then we have a three equations as well. Now another type of equation is quadratic equation. We are already discussed the quadratic function as well. Similar way, an equation in which the highest power of the variable x is 2 or unknown variables power is 2, which is called the equation of second degree or quadratic equation. That is, a quadratic equation is a second degree polynomial equation, meaning the highest power of the variable is 2. The general form of the quadratic equation is ax square plus bx plus c is equal to 0, where a, b, c are the constant but a is not equal to 0. So consider one example here. X square minus 5x plus 6 is equal to 0. It is a quadratic equation because this is in the form of ax square plus bx plus c, which is equal to 0. See, the quadratic equation may be a pure or incomplete quadratic equation. It may be a pure quadratic equation or may be incomplete quadratic equation. In the case of pure quadratic equation, see, this is the equation. See, ax square plus bx plus c is equal to 0. We have a, b, c are the constant and a is not equal to 0. And the highest power of the variable here, it is equal to 2. We have a complete term of a quadratic equation. So we can say that this is a pure quadratic equation. As against the pure quadratic equation, we have the incomplete quadratic equation as well. See, in this case, it is a special case of a quadratic equation where the coefficient of linear term. So linear term is here bx. So bx, here coefficient of the linear term, that is b, is 0. So this bx term will entirely become 0. Then what is remaining here? Ax square plus c. So ax square plus c is equal to 0, where b is equal to 0. B ax square plus c. This is known as incomplete quadratic equation. So the quadratic equation is in the form of ax square plus bx plus c, which is equal to 0, where a is not equal to 0. Now we have a cubic equation. Another type of equation is known as cubic equation. It is the equation is a polynomial of equation third degree, meaning the highest power of the variable is 3. So the general form of cubic equation is ax cube plus bx square plus cx plus d is equal to 0, where a, b, c, d are the constant and a is not equal to 0. If a is equal to 0, then ax cube will become 0, then it will simply become the quadratic equation. Consider one example, 2x cube plus 5x square plus 3x minus 10. So here the highest power of the variable x is equal to 3. So we can say that this is an example of a cubic equation. Consider another type of equation which is known as quartic equation. See, it is a polynomial equation of fourth degree. That means the highest power of the unknown variable is 4. So the general form of a quartic equation is ax raised to the power 4 plus bx cube plus cx square plus dx plus e is equal to 0, where a, b, c, d are the constant and a is not equal to 0. Here it is written as equal to 0, but it is a is not equal to 0. So for example, it is 4x raised to the power 4 plus 3x cube plus 2x square minus 5x plus 2 is equal to 0. So quartic equation can have 0 to the 4 real roots are there depending upon the coefficient. So here the highest power of the unknown variable, that is x, is equal to 4. So such a type of equation is generally known as it is quartic equation. Now we are going to consider some of the examples of linear equation and see how to solve the linear equation with one variable case. See, consider one equation. Solve the following equation, that is 9 into 3x plus 4 minus 2x, which is equal to 11 plus 5 into 4x minus 1. We want to solve this particular equation. See, first we can open the bracket. We can open this particular brackets in the both side of the equation. So it will become 9 into 3x, which is equal to 27x, 9 into 4, which is plus 36, minus 2x here, then which is equal to 11 plus 5 into 4x, which is equal to 20x, then 5 into minus 1, which is equal to minus 5. Now we can simplify it. See, taking the variable terms into the x terms into the left hand side of the equation and the constant terms into the right hand side of the equation, we can rearrange this particular term as 27x minus 2x, taking the plus 2x into the left hand side, so it will be minus 20x, which is equal to 11 minus 5 plus 36 will become minus 36. So if you simplify it, which is 5x is equal to minus 30, and if you divide the both side of the equation by using 5, then x is equal to minus 6, that is minus 30 divided by 5, which is equal to x is equal to 6. Now similarly we can solve the following equation, that is x divided by 4 minus 3, which is equal to x divided by 5 plus 1. See, here we have to move all the terms with the unknown variable x into the left hand side. So here x divided by 5 we are going to take into the left hand side and the constant term into the right hand side. So it will become, see, x divided by 4, taking the x divided by 5 into the left hand side, so it will become minus x divided by 5, 1 plus minus 3 will become plus 3. So here we want to simplify the both side of the equation. So for that we want to multiply both side of the equation by least common multiple, that is LCM, that is 4 and 5. So if you take the LCM of here, then it will become 4 into 5, which is equal to 20, in order to eliminate the denominator 4 and 5. So we are multiplying the both side of the equation by using LCM, that is 4 and 5. So it will become 20 into the left hand side of the equation, which is equal to the 4 into the right hand side of the equation we are going to multiply with 20. So if you go for simplifying it, then it is equal to 5x minus 4x, which is equal to, that is 20x divided by 4, which is equal to 5, 20x divided by 5, which is equal to minus 4x, which is equal to 4 into 20, which is equal to 80. So 5x minus 4x, which is equal to x, which is equal to 80. So our answer x is equal to 80. Now consider the another example. See, x plus 5 divided by 6 minus x plus 1 divided by 9, which is equal to x plus 3 divided by 4. See, in order to solve this particular equation, see, we need a common denominator. That is, we need a number into which all the individual denominator, that is 6, 9 and 4 will divide exactly. So accordingly, the lowest number into which we can divide, see, it is 36. So accordingly we are multiplying the both side of the equation by using 36. So it will be 36 into x plus 5 divided by 6 minus 36 into x plus 1 divided by 9, which is equal to 36 into x plus 3 divided by 4. Now each term can be simplified by dividing the top and bottom terms by the common factor. 36 divided by 6, which is equal to 6, 36 divided by 9, which will become 4, and 36 divided by 4, which will become 9. So it is 36 divided by 6, it is 6 into x plus 5, 36 divided by 9, which is minus 4 into x plus 1, which is equal to 36 divided by 4, which is 9 into x plus 3. Now we can open the brackets here by multiplying the outside bracket term. So it is 6 into x plus 5, it is 6x plus 30 minus 4x plus minus 4, which is equal to 9x plus 27. So simplify it by taking the x terms into the left hand side and constant term into the right hand side. It is equal to 6x minus 4x. Taking 9x into the left hand side, so it is minus 9x, which is equal to 27 minus 30 plus 4. So it will be minus 7x, which is equal to 1. X is equal to minus 1 by 7. So here we can say that x is equal to minus 1 by 7. Now in economics, equations are usually used extensively to model the various types of relationships, behavior and phenomena within the economic system. And these equations can help the economist to understand and analyze how different factors interact and influence the outcome in the areas such as production, consumption, investment, pricing and market equilibrium. One of the most common type of equations which are used in economics is demand and supply equation. So these equations are explain the relationship between quantity of goods and services supplied by the producer and the quantity of goods and services which is demanded by the consumer. And both typically the function of price, which we are already discussed earlier as well. And the equilibrium in the market occur where the demand is equal to supply, leading to the determination of market price and quantities. See, we have a demand equation here. See, we know that the demand equation represents the relationship between the quantity demanded and its price. And typically we are taking quantity demanded is equal to function of price. And it is the function that describe how the quantity demanded change when the price is going to change. In generally we know the demand curve slope downward is showing that they're indicating a inverse relationship or a downward or a negative relationship between the price and quantity demanded. As the price of goods and services decreases, then demand for goods and services will be increased and vice versa. Similarly, we have a supply function as well or supply equation as well. In the case of a supply equation which represent the relationship between how much quantity is supplied and its price. So it can be expressed mathematically, that is quantity supplied is equal to function of price. We're showing that how the quantity supplied changes in response to change in P or change in price. So as usually we know there exists a positive relationship between quantity supplied and the price level. And if we have given both the demand function or demand equation and supply equation, then we can find the market equilibrium as well. And in the equilibrium, it occurs when the quantity demanded is equal to the quantity supplied, and which is leading to the market clearing price or market determined price and quantities. And mathematically, the equilibrium point can be expressed when quantity demanded is equal to quantity supplied, that is both are intersecting. And this equilibrium condition determine the equilibrium price and the equilibrium quantity in the market. So let us consider a simple linear demand function. We know quantity demanded is equal to A minus BP. The negative sign before B indicating that the demand curve slope downwards. There exists an inverse relationship between price and quantity demanded. Similarly, we have the quantity supplied as well, that is C plus DP. We're showing that the sign of D is equal to positive. We're showing that there exists a positive relationship between price and quantity supply. So this is a linear form of quantity demand and quantity supply, or quantity demand equation and supply equation we have. So here a simple linear supply function is given and the demand function is given. In the equilibrium we know quantity demanded is equal to quantity supplied. So we are going to equate these terms, that is quantity demanded is equal to A minus BP, which is equal to quantity supplied, which is C plus DP. So if you go for equating, then we can say that we can isolate the P term into the right side and constant term into the left side. So here constant term is C, so we are taking into the left side, so it is minus C, and we have DP taking the minus BP into the right hand side, so it is plus BP. So here P is common, so taking P into the outside, then we have D plus B into P. Then isolating P, then dividing the D plus B, it will goes to the denominator side, so it is A minus C divided by D plus B. So So this is the market price or it is equilibrium price. Now we can substitute P is equal to A minus C divided by D plus B in the demand equation. So if you go for substituting in the demand function, or either you can substitute in the demand function or supply function. We are going to substitute in the demand function. Then it will become quantity demanded is equal to A minus BP. A minus BP. So instead of P, now we are going to substitute A minus C divided by D plus B. So it will become A minus B. Instead of P, I am denoting or substituting A minus C divided by D plus B. Now taking the common denominator for the A also, so we are going to take D plus B, we are going to multiply and divide with A, then it will become C, A into D plus B minus B into A minus C whole divided by D plus B. If you go for multiplying the numerator side, then it will become AD, AB minus BA minus B into minus C, so it will become plus BC. It will become plus BC divided by the denominator as it is, that is D plus B. So here AB minus BA can be cancelled out. So what is remaining? AD plus BC divided by D plus B. And what is this? This is the quantity demanded in the market, and which is also equal to the quantity supply as well. So this is the equilibrium price and this is the equilibrium quantity. Now let me conclude here. In this lecture, we discussed the basic concepts of equation and the various types of equation as well. And also we are given some of the examples, especially for solving some of the linear equation examples. In the next lecture, we will discuss how to solve a linear equation with 2 unknown variables, with 3 unknown variables. We will see in the next class or next lecture. Thank you.